All right, let's start with homework number 6. This is more review on differential equations and Riemann sums. All right. So number 1. Says the rate of change of the sell price of toilet paper can be modeled by the differential equation. Find a general solution. So we're going to have to take the integral so we can get up, so we can separate the variables. We'll separate the variables first and then take the antiderivative. So I like to get everything set up with the fraction equal to a fraction so I can line up my diagonals and do cross multiplication. Separate the numerator and denominator here. So I have the numerator and denominator paired up, so I can do diagonal here, cross multiplying. All right, so I want T's on the right, I want S's on the left. So it looks like we have a couple things out of place. The P prime of 0.5T, this is thought of as in terms of T, so we'll leave the P prime here on the right side. The S is out of place, so we'll divide the S over, but then the 20 is a little bit out of place as well. I would like that 20 to be on the right side, so I'll divide the 20 to the right and divide the S to the left. Hey Sam, how are you?
Doing well, how are you?
Good. Yeah, let me know if you have any questions, if something's not clear. Yeah, it's unfortunate they use S because sometimes S can be thought of as 5, and there's 5 here as well. So I'm going to try to make it so the S seems look a little different, but sometimes it's hard to do that. Okay, so here we have achieved full separation. S is on the left, T's on the right, everything else on the right side as well. So we're now ready to take the antiderivative. Any questions so far? Okay, integral. This side, we can expect natural log, right? S, a variable to the first power in the denominator is going to be natural log. This, maybe a little bit of use substitution going on because we have that messiness inside the P prime. Okay. But before I jump into natural log on this side, I want to do a little bit of cleanup on the right side. I think maybe it'll help if we don't have to stare at that 20, if we can push that 20 out in front as a coefficient. All right, so natural log on this side. This side, I'm going to do a little bit of cleanup here. I want to get that u substitution set up and set up on that right side. So I'll let the u value be that portion inside the parentheses. Okay, so cross multiply here, solve for dt, I get du over 0.5. Now du over 0.5, the same thing as du over 1/2. And if we do a little bit of cleanup here, we can make this a little cleaner and say that dt equals 2 du. So I'm just going to wait on the left side until the right side is ready. And I'll take the integral all at once. I'm going to resolve this here. 2 over 20 is the same thing as 1/10. All right, both sides are now set up and ready. Left side is natural log. Right side, p prime becomes p of u plus c. Replace the u back in terms of t. All right, so what do I have left? I want to solve for s. So to get rid of that s, I'm going to raise both sides with e as the base. This cleans up to be just absolute value of s. We can split this up as e to the first term times e to the c. And we know e to the c can just be a constant that we can push out as a coefficient. And then we can drop the absolute value and let the c absorb the plus or minus. So we're just left with ce to the 1/10. Any questions with number 1? All right, number 2, it says let y equal k of x be the particular solution to this differential equation. Find the particular solution, given condition -2, 2. And then this is part of another problem where h of x is given. So I'm just putting it here. We're gonna have to refer back to h of x as we get closer towards excuse me, as we get closer towards taking the integral. But first things first, we're gonna just handle the separating variables first. Okay, I'm going to set up using getting my fractions to be lined up nicely. So I'm going to put a 1 here so I can see the diagonals all lined up. Cross multiply. Okay, so at least we have our dy and dx locked in. Those are good to go. And now we just have to decide what is out of place. It looks like the only thing out of place is that y minus 1. We'll just shift that y minus 1 over to the left. But the h prime of x and dx those are already in their right places. So just divide the y minus 1 over. Any questions so far? Okay, we'll take the integral of both sides. There's a little bit of u substitution here, but that y minus 1 is not going to produce anything more than a 1. There's no negatives that will come out of it. There's no other coefficients. So if you recognize that, you don't have to go through u substitution, but just want to, but if we want to double check. Okay, so we just have 1 over u du on the left side. On the right side, h prime, so we're going to refer to h prime from h of x. H of x is x squared plus 3x. We'll find h prime and we'll dump it in here. So simple power rule here, h prime is just 2x plus 3. And I'll put this over here. All right, I got everything lined up and ready to go. Any questions so far? All right, so take the antiderivative. 1 over u is natural log. We go through power rule for both these terms. Clean up, bring the u back in terms of x, and I'll clean this side up as well. Now, on my key, I decided to solve for y first because I know there's a natural log. I'm going to involve e so I can get this cleaned up. But I will say that it looks like for this problem, it may be a little cleaner to solve for c first. And the reason it's a little cleaner is because this order pair, -2, 2, is not going to wipe out all this for us to get a clean C value. So I think maybe it's a little, ultimately you can get to the right answer either way. And if you don't choose the easier way, you can still get to the answer. But sometimes it's just, but ultimately this may not be that much of a difference. But I'm going to try it this way. I'm going to try it solving for C first, because that, if I had a 0 in here, I would prefer, or maybe I'll wait. But here, that -2, 2 is going to be maybe a little bit easier to just get it out of the way here. So. Okay, so -2 in for x, 2 in for y. Natural log of 1 is just going to be 0. Negative 2 plus c. So if I add 2 to both sides, c equals 2. Update my equation, and then I'll take the natural log of both sides. So here comes base e. This drops out, leaving me with just absolute value y minus 1. All this, we can just leave it in that form. Drop the absolute value, but we got to account for it with a plus or minus on the right side. Add the 1 to the other side. Four minus 17. Okay, so now you see how there's a plus or minus? We have to resolve it because these are really two separate solutions. And again, the way that we tell which ones to keep, especially if we're dealing with a plus or minus, is you look at the y value. All right. So the only way that I can plug a negative 2 in and get a positive 2 in return is if this is also positive, right? If this is a negative e, I'm not going to be able to combine these values and get a positive 2. Right. So if we try plugging negative 2 in, the only way it's going to work is if that's positive as well. Okay, does that make sense to you guys?
Yeah.
Okay. Anytime we're solving differential equations, if you end up with a plus or minus, you can't keep both of them. You got to choose one, and the y value will always lead you to where you need to go. Okay, let's go to the back page. All right, toilet paper is being sold at a store. Let P prime be a differentiable function. Smooth curve. Measured in hundreds of rolls per day. Representing the rate at which toilet paper is being sold. Using correct units, explain the meaning of the definite integral from 0 to 10 of P prime in the context of the problem. Approximate the value of the definite integral from 0 to 10 of P prime using left Riemann sum with 4 subintervals. Okay, so we subtract our subintervals, t values there. Width times height all the way down. So width times, let's see, we're doing left Riemann sum. Okay, width times height. So we pick the left y value for every subinterval. Make sure we pay attention to the units here. The number that we're given is measured in hundreds of rolls, so we need to multiply by 100 to get the true value here. Okay, so 3580 rolls of toilet paper sold in those 10 days. Okay, part B, estimate the value of P double prime of 5. So we're given P prime, so P double prime is just going to be the slope of P prime. Okay. We pick order pairs that are closest to that target of 5, so we'll choose 3 and 7. It's also hundreds of rolls. So I'm going to multiply this through so I can get a more accurate number. So if we're ever asked to interpret the meaning, especially if we're dealing with second derivative, just understand that we want to talk about this in terms of rolls per day, and then the negative or positive is going to tell us whether the rolls per day is increasing or whether the rate is decreasing. So in this case, negative means decreasing, right? So the rate at which toilet paper is sold is decreasing at a rate of 42.5 rolls per day squared. Okay, part C. Explain why there must be a value C such that P prime of C is equal to 2. So normally we would think, well, maybe this is mean value theorem or Rolle's theorem, or actually mean value theorem. But the reason why this isn't going to be a mean value theorem is because we only have information about P prime. So it looks like we're going to have to rely on intermediate value theorem. We just want to know does our P prime fall on either side of our target of 2. And we know that if we look at all the P prime values, we have P prime that's above 2, and also we have P prime that's below 2. So we know that between 7 and 10, because we're dealing with a differentiable function, P prime must hit 2 somewhere between 7 and 10, at least once. Maybe it hits in other areas, but if we're talking about IVT, without being able to look at the graph, based off of the limited amount of information we have, we can conclude that there's going to be at least once, right? We can't go from 3 to 1.2 without crossing 2 at some point.
Mr. Yang, I'm sorry to interrupt. I had a quick question about part B.
Yeah.
I think in your problem, you changed like 3.0 minus 4.7. I think for simplicity, you changed it to -17/40. Just multiply the values by 10.
Uh-huh.
But when you multiply it times 100, doesn't that give you a greater value than what is actually the case?
Well, it says P prime is measured in hundreds of rolls per day. So we either can say that this is hundreds of rolls, or we can say it's rolls per day, right? So these should be equivalent, right?
Okay, but if it was like, if I did -1.7/4, and then multiply that times 100, would that?
Let's see. Yeah, if you do -1.7/4 times 100, we should still get the same number, right? Let's see.
Oh, I think I may have added an extra 0. My apologies.
Okay, all right, good. But at least you were asking, so okay. Okay, now part C, P prime of C equals 2. We can guarantee it because we have P prime of C above 2 and P prime of C below 2, so it's got to cross somewhere between. So that's just simply IVT. Right. If you're dealing with IVT, the most efficient way of representing everything, you know what? I think I should have written it maybe in less than instead of greater than. So let me update this. I mean, this is fine, but usually we like to go from smaller to larger. Okay, either is fine, but I think what graders are looking for, especially if you're dealing with IVT, is they want to see that direct comparison, that the target value that you're looking for, you're clearly finding a value below it, and you're clearly finding a value above it, and you're notating where those values are coming from, and then making the conclusion that there must be a value C where P prime of C is equal to 2, and you also have to make a statement about continuity as well. Okay, any questions there?
No.
Okay. Guys, I think I may go ahead and stop here. On Monday, I will do, I'll go over homework number 7 and I'll go over homework number 5. I think Monday there may be more students who want to join, so I'll save homework 5 to discuss Monday afternoon, 3:30. So we'll do homework 5 and homework 7, and then on Wednesday we'll do review worksheet number 3 in the morning before your test. All right, thanks for being here. Hope you guys have a great weekend.
Thank you so much.
Thank
You
you.
too.
Yeah, see you Monday. Bye.